All right, so here in section 8.5, we'll be still solving the system of linear equations, but in a little bit smart mode, because we'll see the Cramer's rule, which will help you to solve the system of linear equations in a better way instead of going by those row operations. So here, so far, what we did, we just tried to do row operations and get the reduced row echelon form every time. But instead of doing that, here we'll do it in a different way. So first of all, before we start, we'll try to understand a terminology for the matrix called determinant. So the determinant of a matrix, what is that? Now here, for an example, let's say this is a matrix. See, we start with a small one, because then later we'll talk about the bigger matrix. So this is a 2 by 2 matrix because we have 2 rows here and 2 columns here. Okay. Now, you can always write the matrix as an equation, which is called the determinant of a matrix. Look at this matrix. We have the first row, all the elements are A1, A2. I'm sorry, first column. And the second column, the elements are B1, B2. Now, to make a determinant, all we do is we just cross multiply them. Do you see the blue lines? We are basically cross multiplying them. So first we just multiply A1 times B2, subtraction A2 times B1. We are basically multiplying, we are basically crossing them, multiplying, cross multiplication. But in the middle, negative sign. That's the determinant. That is called the determinant of a 2 by 2 matrix. We have determinant for 3 by 3 matrix as well, but the format is different. Now, why do you need the determinant? That's probably an important question. At the beginning of the chapter, we just started discussing the determinant. We need the determinant because, as I said, remember, we'll be using the Cramer's rule to solve the system of linear equations instead of going by the row operations. We know that we can solve it using the row operations for sure. We know that. There is no limitations of that method. But we want it to be a little bit more smart. Maybe we can reduce a lot of space and time using the Cramer's rule. So to understand the Cramer's rule, we have to understand how to find the determinant of a matrix. We need to apply the determinant in the Cramer's rule. So that's why we are first discussing how to find the determinant of a matrix. And this is also called the second order determinant because of the 2 by 2 matrix. Now, let's do a couple of exercise here. And I know that we are at this point, since we have been exposed to the row operations, and I think this is not going to be hard for us. So we have 2 matrices here. Let's try the B. Let's try to see whether we can find the determinant of the second one. Remember, we just do the cross multiplication, and there is an ordering. We do the cross multiplication, but you always want to do this one first, and then minus this 2. Okay, there is an ordering. You cannot change the order. So it will be minus 3 times minus 1 minus 2 times 4 or 4 times 2. So let's do that. So you have negative 3, 2, 4 minus 1. So we multiply this first. Negative 3 times negative 1 minus 4 times 2. It will be a number, okay? It will be a whole number. So you have 3 here minus 8. So that becomes negative 5. So that's going to be the determinant of that matrix, 2 by 2 matrix. So it's quite easy. You just follow the formula. Now, next, how we can apply this determinant or the idea of this determinant to solve a system of linear equations with 2 variables. Remember, we already know that we can solve the system of linear equations with 3 variables. We already tried it, right? So last 2 examples we tried to solve the equation with x, y, and z. There were 3 variables. Now we have 2 variables here, but we'll be doing it a little bit in smart mode. Now, before we start, look at the formatting of the equations. These are the generic format of the linear equation. But if you look at carefully, look at the pink one. That's the constant of the equation, C1 and C2. We keep the C1 and C2 at the right side of the equation. Because, you know, changing the side matters here. Because that changed the sign. Okay? So before you start, because, you know, you may not have the equation in this format. If not, change it to this format first. Because when you have in this format, only then you can apply, because otherwise you will have a wrong sign. Now, how you solve it? Look at, so from this equation, once you have this equation, this is your formula, and that's simple, because if you apply this formula, you will know what is x. Straight. No row operation, no more steps. You can just, you see, this is, you have to find a determinant here, right? And you have to find another determinant here. But look at the rows and columns carefully. What do you did? For both an x and y, the denominator is exactly same. But in case of numerator, look at this one. For the x, if you look at carefully, the first column is coming from the constants. And the second column is the column for the y. When you are finding the x, the first column, you know, the first column here is the column for constant, and second column is column for b. And when you are finding the y, you still have the column for constant, but that is in the second column, because, you know, the ordering is important here. If you change the ordering, you will have a different sign, because you will be multiplying and there are different signs. If everything is like this plus this, there will be no difference, but here there is a negative sign in the middle. So here the C1 and C1 in the second column, but again, be careful. When you are doing y, you are taking the column for x. But when you are doing x, you are taking the column for y. And they are in different order here. But if you do this, you are done. You will be able to solve the equation. Okay. Now let's look at an example, and this is, again, we know that we can solve this equation using the row operations. We already did that, right? So these are only two. There are only two system of linear equations. This is a system of linear equations with two variables. So let's try the Cramer's rule here. We don't need any more steps. We'll just write one equation for x, and we'll just write one equation for y, and then we'll be done. So if you write the equation, I'll go back to the previous slide so that you can see the rule, Cramer's rule, and you can apply it. Let's write this here as well. Okay. 2x minus 3y equals to negative 11. X plus 2y equals to 12. Okay, now let's go back to the previous slide so that you can see the Cramer's rule here for solving a linear system of two variables. So, all right, so we have our solution. Okay, so let's write the formula for x here. So A1, A2, I'm writing the denominator. So the denominator is same for both x and y. So that 2, 1, negative 3, 2. Okay. Numerator is different. So for the x, that's negative 11, 12 for the first column, and the second column is going to be negative 3, 2. And for y, first column is 2, 1 of the numerator, and the second column is negative 11, 12. Alright, so here let's to the next step. So we cross multiplication. We do the cross multiplication. There is a negative sign. This is negative 22 plus, because there are, okay, let's write it 2 minus then, so you understand. There are 36, right? And this one is 4 minus 3. Here, this is 4 minus 3. This is 24 minus 11. Now, negative 22 plus 36 over 7. 7 and then 35. So this is going to be 5. So the y is 5 and x is 2. You have the same answer? So it's pretty much simple compared to the row operations one. So these are the same question. Let me look at the new one and then we'll do some more practice. Now this is the same. We still have the same Cramer's rule, but now we have a system of linear equation with 3 unknowns, 3 variables. So that's why we call it third order determinant. So before we start with that Cramer's rule, we first want to understand how to find the third order determinant. It's a little bit more complex than what we did before, because we have several steps here. Now let's say this is your 3 by 3 matrix. This is your 3 by 3 matrix. Now this is how you find the determinant. Now how you exactly do it? Let me show you an interesting thing here. Look at this. If you look at here, see this is your 3 by 3 matrix, and this is your determinant. Now how you exactly do the determinant? You don't have to memorize anything. Look at this. When you take A1, you will be basically taking A1, A2, A3 for 3 different components here. Okay. When you take A1, what do? Look at this. We are canceling the row and column where A1 exists. Do you see that? Look at this. I'm taking A1 here, and I'm just eliminating the row and column where A1 exists. I'm taking the remaining part. Do you see it? Look at this. I'm taking A1, I'm cancelling the row for A1, I'm cancelling the column for A1, and in the determinant brackets, I'm taking the remaining things. When I'm taking A2, the only difference is here, this is a negative sign and there is a positive sign. It's something like positive, negative, positive. But when I'm taking A2, I'm exactly doing the same thing. I'm cancelling the column for A2, and cancelling the row for A2, and then I'm taking the remaining thing. Look at this: B1, C1, B3, C3. That's really easy to think. And when I'm taking A3, again I'm doing the same thing. I'm cancelling the column for A3, cancelling the row for A3. I'm eliminating those 3, and I'm writing the remaining elements. And that's exactly what the formula is. Even for me, I never even remember this formula. Every time I just try to think like this. Whenever I see a 3 by 3 matrix, I just try to write the formula like this, based on what you know. And then once you have this, the remaining steps are simple, because now you are reduced to A1 times 2 by 2 determinant of 2 by 2 matrix, right? Because you will be just doing this, right? Cross multiplication with a negative sign in the middle, right? So let's try some example here. Let's say this is a 3 by 3 matrix. We'll first want to find the determinant for this. Remember, we are not solving the system of linear equations at this point. We are just trying to find the determinant at this here. The reason we need the determinant again is we'll be using the determinant in the Cramer's rule to find the solution of system of linear equations with 3 unknowns. We did it for 2 unknowns. Now we are trying it for 3 unknowns. We'll have to find the determinant of the 3 by 3 matrix for that. Remember, we'll be using the column 1. Okay? Now when we take the first entry, first element of the column 1, we will eliminate. So let's say the first element is going to here is -2. When we take -2, we will eliminate the first row and the first column, right? We'll take the rest as a determinant. When we take 1, we'll eliminate this column and this row. We'll take these 2 and this 2. When we'll take 3, we will eliminate this column and this row. So every time, whenever you are taking an element from the first column, you'll be taking all the 3 elements from the first column. You'll be eliminating the rows and column of that element. And you'll take the rest as a 2 by 2 matrix, and then you'll find the determinant for that matrix. So let's write the 3 by 3 matrix here. You may wonder that if we have such a smart way of finding solution of system of linear equations, why we still need those Gauss-Jordan elimination method we learned in section 1.8.1. Any comments? Any guess? Probably we don't need it, really? Look at carefully. Cramer's rule can be applied in a 3 by 3 matrix, 2 by 2 matrix. What happens if you have a 3 by 4 matrix? 2 by 4 matrix, you see what I'm saying? So here, the row and the column numbers are same. What happens if it is larger? For those cases, still the 8.1, the techniques we learned there, the row operations are still valid. So don't assume that those are useless. So those are still useful. These are some smart techniques, but these can be applied in special occasions, special cases. Okay? So you cannot still ignore what we have learned in section 8.1. We still want to learn all of those. Now let's write this 3 by 3 matrix here, and let's write it on the other side. Okay, let's write this 3 by 3 matrix: -2, 1, 0, 1, -1, -2, 3, 1, 0. Okay. So we are trying to find the determinant of a 3 by 3 matrix. Alright, so let's see whether we can find the determinant here. So how should we start? We'll first take -2, and then we will eliminate this row and this column. So we'll be taking only these 4. Right? So we are taking -1, -2, 1, 0. And then negative sign. What is the next item? You know, we'll be taking all the elements of the column 1. So the next item is this. Is 1. Now, we will again eliminate this column and this row, right? So what is left? These 2 entry and these 2. The last item is again with a plus 3, and now we will eliminate this column and this row. So we'll be taking the rest, other 4 here. 1, 0, negative 1, negative 2. Once we have it, because we reduce the problem into, like right now we just have to find the determinant of 2 by 2 matrix. So okay, so here let's write the determinant for 2 by 2 matrix. So it's 2 times what we are multiplying. Remember the cross multiplication. The first cross multiplication is 0, negative, negative 2. So this becomes 0, negative, negative 2. The second one is 1 times 0 minus 0. I'm just writing everything. So 3 times the last one, 1 times negative 2, which is negative 2 minus 0. So here we have negative 2 times positive 2, which is negative 4. This is 0. And this is negative 6. Is this negative 10? Everyone has the same answer. So this is how you will find the determinant of a 3 by 3 matrix. Okay, so you have, let's see. So let's try to see an example of the system of linear equations with 3 variables using the Cramer's rule. Now here we still have the system of linear equation for 3 variables. Now what do you do is at the beginning we have to find these 4 different determinants. Now you see here all of the determinants here are itself a 3 by 3 matrix, and we now know that how to find the 3 by 3 matrix. We now know how to find the 3 by 3 matrix, determinant of 3 by 3 matrix. Now what we are doing exactly, look at this. For the D, so you have to find 4 determinants, and we have a different names for those. The first one is D, second one is dx, dy, dz. That's how we name it. D, we are taking all the blue coefficients. So basically we are taking all the coefficients in the left side of the equations, just following their order. We are not changing any order. Look at this. We're just writing as it is. So we just write all the equations aligned, x, y, z. We are taking all the blue ones. Now the only one change is when you are taking for x, you will exactly have everything as it is, except the column for x is going to be replaced by the coefficient 1. When you are taking the determinant for y, everything will be saying except the column y. This is the column for y, right? That's going to be replaced by the coefficient column. When you are taking the z, determinant of z, everything will be same except the column of the z will be replaced by the coefficient of d. So it's not, nothing is hard to remember. You don't have to memorize it. I think it's easy because we just started with the d, which is easy. Once we have the d, rest is simple because we just have the same matrix, except whenever we are calculating x, we just replace the first column by, because that's the column for x. We replace the column for x by the column of the coefficient. For y, we replace the column of y by the column of coefficient. Z, in case of z, we just replace the column of z by the column of coefficient. And then we have now 4 different matrices. Each of these are 3 by 3. And then we can find the determinant for each of these 3 following this step, right? Following this method. So there will be 4 different numbers, right? I'm saying for d you have some number, for dx and something else, dy something else, dz something else. Once you have those 4 different answers, your solution is extremely simple. Look at the solution. X is nothing but dx by d. Y is nothing but dy over d. And z is nothing but dz by d. You just have to have the determinant of all these 4 matrices. And once you have it, the solution will be ready right away. Okay. Let's see how much time we have. So let's see. Okay, let's try this as an example. So here we have a system of linear equation with 3 unknowns. In some equations we don't have z. That means the coefficient of z is 0. So once we have those, we can. So let's try this. Let's say we first try to solve only for the x. I think the rest will be also simple. We just need to have their determinant. So let's see whether we can find it, and then we'll stop it here, and then we'll resume from the next slide in tomorrow, next class. So we just need d first, because for all of those equations we need d. What will be d? -2, 1, 0. Second equation, 1, -1, -2. Last equation. So this is going to be your d. Now let's try to find the d first, because we don't have that many space in the board. So let's see whether we can find this. It's going to be 2. Can I do it a little bit faster? Because I can just take 2 and I know this is going to be the 4. We multiply these 2. That's going to be 0. -, -2. When I take this, I know this is going to be multiplied, right? This is going to be multiplied, so that's going to be 0 minus 0. When I'm taking 3, is this the same matrix that we solved just before? I think is this the same matrix? The one that we just solved? Yeah, they probably are trying to give us the same example. So we don't have to solve it again. I think we already solved it. What was the answer? -10? -10. So I think that's the same matrix. We just solved the same matrix for the previous example. That's the 10. So let's try to solve the dx then. Now the dx here, so we'll be replacing the column 1, except that everything is, because this is the column for x, we'll be replacing that by the column for the coefficient. You want to know how to get the -10? No. The coefficient. Look at the coefficient here. So we are replacing that column by 1 to 6. That's the column for the coefficient. Everything else will be same. So all right, now to get the coefficient, or to get the determinant, so when I take 1, I'll be multiplying these 2, minus 2, negative. I take 2, multiplying these 2, 0, multiplying these 2, which is again 0. The last one is 6. I eliminate this column, last row, first column, last row. Multiply these 2, which are -2, minus 0. Now we have 2 here. This is 0, right? And the last column we will get -12, right? So we have -10 here. So we now have the solution for x. Now what is the solution for x? dx divided by d. Now the dx is -10, d is also -10, so the x is 1. Any question here? Again, what we did, we just took 1, multiplied this, negative, multiplied this. When we take this, multiply this, negative, right? When we take 6, multiply this, negative, multiply this. Be careful, the middle one has a sign of negative here. So that's for the x. So to find the y, we have to find the dy, right? What will be the dy for us here? Dy is going to be, let's see, the first column will be same like d. So this negative 2, 1, 3. Middle column is the column for y, will be replaced by the column of coefficient, which will be 1, 2, 6. The third column will be as it is, like 0, negative 2, 0. Now, if we are trying to find the dy, what do you do? Negative 2, multiply this 2, which is 0, minus, multiply this 2, which is negative 12, minus, this is 1. Now we multiply this 2, which is 0, minus 0. And then I take plus, this is 3. Now I multiply this 2, which is 0, minus 6 here. Oh, minus 0. Oh, wait. I take 3, right? I multiply this 2, I'm sorry. I multiply this 2, which is negative 2. Multiply this 2, which is 0. So let's see. Here we have 12 times negative 2, which is 24. The middle one is 0. Here, this is negative 6. So this is negative 30. So the y is dy by d. So the dy is negative 30. D is negative 10. Y is 3. So for the z, we have to find the determinant for determinant dz. Once we know the dz, we'll divide it by d. Can you try for z? Try it for z and see. I think it will be a simple number. Yes. Yeah. And also don't forget, there are quizzes. We still have to finish the quiz for chapter 5 and chapter 8. Check the dates. I think the dates are 26 and 27. I extended the date because before it was Sunday for chapter 5. I pushed the deadline right now. For the chapter 5, the quiz is due tomorrow night. And for chapter 8, it's due on 27th night. And you have to little bit rush for the homeworks of chapter 8.1 and 8.5. Now you can try the 8.1 for sure. You can also try 8.5. So this is going to be the last problem we are trying today, and we'll start from, this section is not done yet, so we'll cover the remaining part of the section tomorrow. And then day after tomorrow, we'll probably talk about any problem you have, any mathematical problem you have. So we have x here, which is 1, y is 3, we know it. We just want to find z, and to find the z, we just need to find the dz, right? Can I erase this one? Let's make it y. So this is going to be the column. Okay. So that is dz. Let's say for dz. Okay. Now dz, we'll have the same column for the first two columns. So we'll have the same element like d. Last column is going to be replaced by 1, 2, 6, which is the column for z. We just replace it by the coefficient. Now let's do the math. So let's find the determinant. Negative 2, we multiply these two, which is negative 6, negative 2, and then negative 1 times, multiply these two, 6 minus 1, 3 times 2, negative 1. Now here it's negative 8 times negative 2, which is 16, minus 5 plus 9, which is 20. You have the same answer. DZ is 20. I'm talking about the DZ. Yeah, that's 20, I think. That's why you have negative 2, right? So the Z is DZ divided by D, which is 20 over negative 10, which is negative 2. I think the Cramer's rule is easier compared to the row operations because you have to do a lot of steps there, and you might, the chance of getting an error is extremely easy there. So let's stop here. Anyone has any question? Okay, so let's stop here and we'll resume from the next slide in the next class.